got a Lennox furnace here, and apparently what's been happening is the unit's been working intermittently. I didn't diagnose this, so I'm just here to do the work, but this flame sensor was in there. As you can see, it's not the OEM. So from what I've been told, it hasn't been producing enough microamps, enough DC microamps to tell the board that there's flame. So we've ordered a OEM one, which is a 52W29 from Lennox, and supposedly this is going to work a little bit better. I do notice that it is a little bit shorter, so we're going to go ahead and test it and make sure that everything's good. So we're going to go ahead and install it. So here we go. Okay, so we got it all set up. So we have one side of the meter clipped to the actual flame sensor, the other one into the wire, so we have it in series, and then we've switched it over here to UADC, so that's microamp DCs for my unit here. So we're gonna go ahead and power it on. Okay, so we're calling for heat. Now I believe we're supposed to be getting 7, a minimum of 7 is what it asks for. I think. I don't remember off the top of my head. Maybe it was 7 to 10. I don't remember. Well, I'll flash it. I'll look it up. And here it is, right there. That's what it's supposed to be. So let's go ahead and let this thing light up, and hopefully it stays lit this time. Okay, yeah, so I just spoke to the last tech. From what they said, Lennox said that I've never seen one, that high, but it's basically supposed to be 9 microamps DC. 9 to 10 is the acceptable range, but every Lennox I've ever worked on is usually around 3, and this one's averaging about 2.5-ish. It did go out. Oh, this went out. So yeah, so the next thing I'm going to check is I'm going to see what the voltage is on the flame sensor itself. So go ahead and unplug that. So we're going to get it set up to test the voltage, and we're going to check the AC voltage going to the flame sensor, because it's possible that maybe this board's not sending enough voltage, so that's why our reading's so low. So yeah, so I'm going to go ahead and do that. Okay, so I've got the wire back on there, and I've hooked that up to my connector. And then we'll go from there. We got the AC voltage, then we go to ground, and I got about 88 volts, so we want 90, so it's close. So yeah. Okay, so we've cleaned the burners, tightened all the grounds and everything. So now we're gonna just see if it stays lit. I started the timer. So yeah, that's all we can do at this point. If this fails again, the next step is to try to replace the control board. But the weird thing is I'm getting plenty of voltage. So, and I'm getting 3 microamps, which in my experience is more than enough for this. I think the minimum's usually 1.7, 2. But yeah, the last tech was telling me it's supposed to be a minimum of 7. So it's very rare that I've seen something that high. So we're just gonna let it run and time it and see how long it lasts until it flips off. So we've been going now for about a minute. So hopefully it stays on. Maybe it was just the dirty burners. Well, she only lasted almost 5 minutes, and then she went out. Okay, so I have the meter set to minimum. So it's going to show the lowest reading it gets. So right now, the lowest it's dipped is 2.1. So we're going to see if it gets below that. Because most units, you want at least a minimum of 1.7. So, and I'm on hold with Lennox Tech Support, so we'll see if I'll ever get through. So yeah, I've even tried. Oh, no, we're still holding. So yeah, I even tried switching these around. So we got the timer going, so it's at 2 minutes. So we'll see. Alright, so I'm watching the voltage on the gas valve. I just want to make sure that it actually loses voltage. Maybe something's up with that. Next thing I check is the pressure switch. I'm just going to start checking other things just to make sure that, you know, nothing else is causing the gas valve to cut out. And it's been averaging, it lasts about 5 minutes and then goes out, so we'll see. Okay, so the voltage is cut from the gas valve. So something is cutting the voltage. So we're gonna watch that pressure switch. I just want to make sure it's nothing else that's causing it. So what we'll do is we'll replicate a pressure switch failure by unplugging it while it's burning. See what it does. Okay, so we have 0 volts. That means it's closed. And the fact that our igniter is coming on tells us it's closed. So we're going to watch this pressure switch, make sure it doesn't pop open. So I have an HS36, so it never shows 0, but see the amp, that means it's millivolts. So I'm going to go ahead and put it on max. So if it jumps up like significantly, it'll hold it. Well, she's been running for 6.5 minutes, which is the longest run time I've had so far. Still on hold. I'm wondering if maybe there was a loose connection. It would just trip for a second, and that's why it wouldn't trip a error code. Because the entire time with the flame sensor, I'm getting microamps. There's no point where it dips down below 2.1, and that was very rare that it would dip that low. It was just every once in a while. So I don't think the issues with the flame sensor. I think I had a loose connection somewhere, and maybe I tightened something, or it could even be maybe the Molex plug on the board is kind of messed up. But I'm gonna try to let it run for like 10 minutes and see what's up, and then I'm gonna go through and just tighten up everything. But I'm wondering if maybe it was the pressure switch. So pretty much the only thing that can interrupt the gas valve is going to be the flame rollouts, the high limit, and the pressure switch, and the flame sensor. I'm getting a reading on that flame sensor the entire time. It's not like dipping out or going extremely low, so I don't think that's the case. I think something else is going on. Alrighty, so I just got off the phone with tech support. Minimum microamps DC for this is going to be 1.5. It's been running for 20 minutes straight. This was our culprit. The connections here were kind of loose, so when it would vibrate just right, it would kill the voltage for a second, and that would immediately kill this, and then it would start all over again. So it turned out that the flame sensor was totally fine. So looks like we just had a loose connection here. So anyway, always refer to the sequence of operation. Don't always use the diagnostic light. You want to think about, what's the order of sequence for the sequence of operation, and what our symptom is our gas valve would cut off because something was cutting it off. So that the flame sensor can cut it off, the pressure switch can cut it off, and a high limit and a rollout could cut it off. But we weren't getting the symptoms because if it was a high limit, the blower motor would run. So it's just a kind of a process of elimination. So you got to use that to your advantage. Don't always depend on the diagnostic light. So anyway, it's back up and running. 21 minutes, good to go. Thanks for watching. Make sure you like and subscribe. Comment, tell me what a horrible technician I am. Hit that bell notification and follow me on Instagram and Facebook. Thanks for watching. Bye.